So here's the doubler class. Let me make one. And I'm going to say ask D, quote, say, quote, hello. It says, hello, hello. The only purpose of this example is to show you that ask can take extra arguments. And what those extra arguments do is they correspond to formal parameters in the method. So this is the first time we've seen a method with a formal parameter. It works just like formal parameters of any procedure. So stuff has the value of this expression, which is the word hello. This isn't a very interesting object. In particular, there's no reason to ever make more than one of it because it has no local state. So one doubler is exactly like another doubler. This is a kind of functional object. And the doubling happens because of what's in the body, where you say sentence, stuff, stuff. Okay? Everybody with me? All right. Okay, so here I'm redefining the counter class. So let me go ahead and define G4, instantiate counter, define C5, instantiate counter, ask C4 quote next. So it seems to be giving the same number twice every time we call next. And now I'm going to ask C5 next. And you'll see what the two numbers are all about. The first one is specific to each counter. Each individual counter starts at 1. The second one is a count of all the times any counter has counted. So if I go back to C4, I get 6, which is the number after this 5, and I get 7. There's been 7 nexts on all counters altogether. Okay? And what's new to make that work is this class vars. So class variable is an idea. And class vars is the clause that implements it. Class vars looks just like instance vars, which looks like the first half of a let, except that the meaning is different. Namely, there's one variable total, which is created as soon as I do the define class. Instance vars are created when I call instantiate. So every time I say instantiate counter, I get a new count. But total, there's only one total. It belongs to the entire class. It's not a global variable. If I say total, it says unbound at the scheme prompt. But it belongs to the class, and each member of the class can use it. Okay? So this is good for situations where you want to keep track of something in common to every instance of a class. It's a useful idea. I can ask a particular counter for the value of total. I can also ask the class for the value of total. So you see now that classes accept messages just the same as instances do, not the same messages. I can't say ask counter next. It will give me bad message to class next. an error message. But I can ask it total, because that's something that is shared by all the instances. Okay? Oops. Okay, so moving on. Define BH. Instantiate person, quote, Brian. Okay, so there's a person class, and there's 3 methods for the person class. So I can ask BH, say, I love scheme. And it does. That's not very interesting. The method is just stuff. Right? Say stuff, stuff. I can say ask BH, quote, ask. Notice it's a complete coincidence that the name of this procedure to get objects to do things is the same as a message in this particular object class. Nothing to do with each other. Ask BH, quote, ask. Study for the midterm. And it will say, would you please study for the midterm? Because it uses self, which goes in some list someplace, over here. Self is a kind of hidden instance variable that every instance has, whose value is that instance itself. So the ask method doesn't just return, would you please stuff. It asks itself to say that. And that's going to become important in just a moment. And then the final one is greet. I can say ask BH, quote, greet. No argument. And it says, hello, my name is Brian. Just a note in passing, what's the name of this instance? Tricky question, right? It has 2 names. One of its names is BH, which is the name of a variable whose value is that object. And that's the name we use to get at this object from the outside. And then it has an instantiation variable name that's kind of its internal name. And that's the one that it knows about. It has no idea, as usual in Scheme, it has no idea that there's a variable whose value is itself, other than self. It doesn't know anything about the variable BH, which is a global variable, not an instance variable or class variable. But it does know that its name is Brian. So these particular objects have internal names and external names. Define PP, instantiate, stands for Porky Pig, Pigger, quote, Porky. Now, what does a pigger do? Well, it has a say method. And its say method basically says, call the piggle method on every word of my input. If the input is a word, just call piggle on it. Otherwise, map calling piggle over it if it's a list of words, a sentence. It really should say every. That's a boo-boo. So I can say, ask PP, quote, say, quote, I love the Beatles. And it will say, I of lei the Beatles bay. Okay, so that's how its say method works. Now, notice it does not have, in this class definition, an ask method or a greet method. Nevertheless, I can say ask pp, quote, ask, play more Beatles music. It says, udwe uye is play, a play, or may, Beatles bay, music may. All right? How does it do that? It does that because of this clause. So we have a new kind of clause, which is parent. And that's a technical term also. This has to do with the question of inheritance, which is the third leg on which object-oriented programming rests. And this says a pigger is exactly like a person, except for the methods defined here. So persons don't have a piggle method, so only piggers know how to do that. Persons do have a say method, but we don't use it. We use this different say method that speaks in Pig Latin, right? So what about ask? Well, if we back up just a bit, here's the ask method for people. It says, ask myself to say this. Remember when you saw this originally for people, you thought, huh? You know, this is, why go through this effort of asking myself to say when say just returns its argument without doing anything? Now you see why. When a pigger gets an ask message, it uses its parent's ask method. But inside that method, self is a pigger. So if I ask myself to say something, it says it in Pig Latin. Okay? Pretty cool, huh? Just want to show you the problem, which is ask pp, quote, greet. So we want it to say, hello, my name is, and nothing happens. It's in an infinite loop. Why? Because we have a very primitive idea of what a vowel is, and so the word my doesn't have any, and so this thing is buzzing around trying to convert my to Pig Latin.